Alrighty, so here we go with the VT graph checkup. Now I think for the most part, just sort of gauging the activity in the room, I think you guys did fairly well overall. Would you not say? How many people got more than 5 out of 10? Really? Yeah, I guess I gauged that wrong. Okay, never mind. Let's go through it a little more carefully. I thought you guys did better than that. All right, so remember that I know there was one group, you ladies, said it took you halfway through before you realized it was a VT graph, right? Yeah, how many other people realized late that it was a velocity time graph, not a DT graph? Okay, so I did that on purpose. Not to fool you, not to trick you, but to remind you that the DT graphs are not the only one there is, right? So yes, this is a graph of velocity. Okay, so acceleration, remember, is the what of the VT graph? Slope. Very good, Parker. It's the slope of the VT graph. So you see VT graph, you see acceleration, you got to start thinking slope. So from 0 to 4 seconds, we are talking about the slope of that line, which is a straight line, so that's handy. So what is the slope of that line? It goes down to 2. It comes from 10. That's down 8, right? So minus 8 over, and the time is from 0 to 4 seconds. So it's going to be minus 2 meters per second squared. Right? I think, am I safe to say that most people got that one? Mm-hmm. Once you realize what was going on a little bit, that's probably the easiest one of the bunch. Okay? All right, now the next one is A bar from 10 to 16. Now this one, you'll notice, the velocity time graph is curved here, right? Now we're not talking about instantaneous acceleration, we're talking about average acceleration. So once again, we're talking about slope, Riley. So the slope from 10 to 12 seconds. Now because it's curved, I'm going to have to do what? I'm going to have to draw. Do I really have to draw the line? No. Could I do it without? Absolutely, but certainly visually it's a little bit easier to sort of see kind of thing. So I'm going up to 0, right? And I started at minus 8, so I went up 8. I went up 8 squares up. How far over did I go? I went from 10 to 16, so that's a total of 6. So I've got 8 over 6, and what's your answer? I think it's C. Is that right? Okay. But going too fast for anyone. Just about right? You're making some sense? Calvin, you look pretty excited about this. Now here's where things start maybe got a little bit crazy. Delta D from 0 to 4 seconds. How do you find displacement from a velocity time graph? Anybody remember? Area. Right, you are correct. Area from 0 to 4 seconds. You still got it wrong. Did you forget that you have to go all the way down to 0? Yes. Okay. And that's okay. Well, not the swearing part, but it's okay to make that mistake because you won't make it again, right? This is just practice, right? No problem. There's a little boo. Not a problem. Okay, so we're talking about the area of that triangle and the area of the rectangle. The rectangle goes from 0 to 4, so it's 4 by 2. So the rectangle is 8. The triangle also goes from 0 to 4. From 2 to 10 is 8. 8 times 4 is 32. Divide that by 2 is 16. Why do I divide by 2? Because it's a triangle, and you should get 24. Was that the right answer? It's such a maybe actually got my answer. So far, so good? Nod, yes. Now I get it. Now I remember it. Yeah, Chris? Number 4, delta D from 0 to 10. Now, what do we do when there's part of the graph above and part of the graph below? Courtney, do you remember? What do you do when part of the graph is above and part of the graph is below? We now know that we're talking about the area. What do I do with the stuff that's below? Do you remember? I'll show you what not to do. Some people want to do this. They want to find the area of all that stuff to there. Is that right? How come? It's only the area between the graph and the what?
Zero.
And the 0 axis, right, 100. Okay? Yeah, so what we're talking about is we're talking about this bit right here, which we've already figured out to be, what did we say? 24. And then we're talking about, I still got this squeaky stool. Remember talking about this little guy right here, which is from 4 to 7 is 3 times 2. I think that is 6. Am I right? Okay, now what do we do with this bit here? Well, now we're talking about this little bit right there, and then we're talking about this guy right here too. And as Hunter pointed out, it's that bow tie thing, okay, that you might vaguely remember because you have some vision of some nerdy guy wearing a bow tie. No? I think bow ties are, you know, I think they've gotten a bad rap. I think they're kind of cool. No, you don't think so? You disagree? I'm not sure the bow tie was ever a fashion. Maybe in a tuxedo. Anybody remember what we do? What's the rule? You could try and figure out what this point is right here. You'd like to think it's exactly halfway, but I can tell it's not because that point doesn't go right to that point right there. So how did we do that? Well, remember the rule was find the base. We're talking about 5, 6, 7. We're going from 7 to 10. So my base is equal to 1, 2, 3, right? And then the rule was take the height of 2 minus 8. So the height, we say 2 minus 8. We're going to say our height is minus 6. And then we take those values and we go 3 times minus 6. And we divide by 2 because it's a triangle. Okay? And there's a real long mathematical geometrical proof of why that works. I'm just going to tell you that it works. I think you'll trust me. And I believe that bow tie should have an area of minus 9. Okay? I'll go through it all again. Giving us a total of 24 and 6 is 30, minus 9, 21. 21 meters. And yes, I'll do that bow tie thing right again. Okay, so the bow tie thing, you take the total length of the base from left side to right side. Okay, we're starting at what point here, Riley? 7. We're going all the way to the 10, which is a base of 3, right? 7 to 10 is a base of 3. Okay, now the height thing, you take the highest point, which is 2, and the lowest point is down to minus 8. 2 minus 8 is minus 6, right? So it's like the net height is minus 6, right? The net height is minus 6, and then you multiply those together. The base is 3, the height is minus 6. 3 times minus 6 is minus 18, divided by 2, and it's minus 9. What you're really doing is you're taking, I'm going to put the blue one here. You're taking that blue triangle, and you're sort of flipping it over, and when you flip it over, that's what this 2 minus 8 thing does. Okay? I would have to spend probably 45 minutes showing you the mathematical proof. You don't want to see that. Okay? But that's all you do. Works out nice. So 2 minus 8 is minus 6. Times that by the base of 3. 3 times minus 6 is minus 18. Divided by 2 is minus 9. And then you take that, and you have to add it to these ones as well, right? And we've already figured those out, 24 and 6. So we get 21. Remember that from grade 11, vaguely? Okay. Yeah? All right, number 5, 8 inst at 9 seconds. How do we find instantaneous acceleration? Again, we're talking about slope of a BT graph. Because it's at 9 seconds, we have to find the instantaneous slope at 9 seconds. Well, we're lucky in the sense that it's a straight line, right? So it's already a straight line, so you simply find the slope of the straight line. Right? So you're going to find the slope of that line there. Okay? So I go from 2 to minus 8, so that's a total drop of minus 10, right? We're not doing the same thing as before. It's the total distance now, right? So it's like 2, 4, 6, 8, 10, dropping 10. Over a run of 7 to 10 is 3. So minus 10 over 3, minus 3.33. All coming back to me now, right, Justin? Excellent. A inst at 14 seconds. I've already got the little dot on there. So if it's at 14 seconds, it's curved. How do I handle that one, Jesse? Justin? Tangent line, very nice. Sorry, Justin. Jesse, he beat you to it. Okay, I drew a terrible tangent line. You would have to draw a better one, right? Pick 2 points. Does it matter which 2 points you pick? No. Try to pick nice lattice points, but if you can't, just sort of guess a little bit. It's the process that I'm interested in. And, well, we know it's positive, so it's either B or C. Does anybody? I have C, this one here. Right? You're going to pick 2 points, and you're going to find the slope. Number 7, the inst at 2 seconds. 2 seconds right there. Once again, it's a straight line. From 10 down to 2 is a drop of minus 8. And from 0 to 4 is 4. That's a negative 2. Looks like for once I've made a multiple choice thing where all of the correct answers are there. Confused on that one? Oh, did I screw up? Courtney, it's not even 9:30 and you found my first mistake of the week. Oh, golly. What should I have done? Maybe I made that mistake on purpose. No, not that time? Can you tell when teachers make that mistake on purpose? No? Sometimes we do. Yeah, I made that mistake. I apologize. Good catch, Courtney. It's V inst, it's a velocity time graph. At 2 seconds, we're just going to read it off the graph. The correct answer is C, which is maybe even worse, the fact that I have the answer right in front of me, right? What if I got it right on here? I just didn't look at the answer. Clearly, I can eat more coffee.
Drink coffee.
You drink coffee.
No, you said you eat coffee.
Well, I said clearly I need more coffee. I get the bad caffeine withdrawals if I don't drink coffee. All right. What about V bar, Courtney? How do I do that one? I don't want to make a mistake now, so I'm gonna ask you. Is V bar different from V inst?
Yeah, a little bar over
Okay. Well, what does that mean, Justin? Yeah. Justin's looking on his little sheet thing here. That's a good idea. It's V bar, right? Average velocity. Well, can't I just go like 10? The velocity at the start is 10. The velocity end is 2. The average of 10 and 2 is 6. Is it not just 6? 10 plus 2 is 12. Divided by 2 is 6. Is that what it is? No. Is that the answer?
It's decreasing unless it's negative.
No, it's not, Troy, because the velocity time graph is above, so it's positive. You're thinking about a DT graph, right? How do you find? I'm going to grab Justin's here because mine's not too available. Let's just double check that I've done this right here, right? We're talking about a velocity time graph, right? So the right-hand column and average velocity, distance over time. So what do I have to calculate first? You got to take the distance first. Which one was it, Darren? D, that's number 3, right? So I have to find the displacement there, which was the answer to number 3. It's 24, right? Divided by the time, which is 4 seconds, which is 6 meters per second. It just happens to be, but that's the way you got to do it. Okay? You can't just take that one and average them together. Okay? You can't do that. What if What if I asked you to find the average velocity from 0 to 7? Could you just go 10 and 2 and get 6? No, because you'd have to deal with this flat velocity here, right? Okay, so it doesn't work in that situation. You'd have to go the 24 here, plus whatever that was. I think it was 6 actually. You'd have to go 30. Right? So you can't do that. You got to find the displacement over the time. I'm glad we went through that. V-bar from, last one, 0 to 10 seconds. Oh, and that's exactly what I'm talking about here, right? You can't just go average of 10 and minus 8. You can't do that. What do I have to do? I got to find that displacement, which I think we've already calculated, haven't we? Was it 21, am I right? 21. 21 was the total displacement all the way down to there. Divide by 10 is going to give us 2.1 C. 2.1.
Oh, calling it a day.
Yeah, calling that a day?